All right, everybody, we are going to look at skill 5, which is measures of spread. And so we'll talk about what that means momentarily. But first, let's start with the scenario. In the last lesson, we talked about how many hours of Netflix students watch on average. A group of 6 students reported the number of hours watched. The mean of the number of hours watched for the group was 5 hours. Okay? So that's the scenario here. And it says if the mean number of hours watched was 5 hours, does that mean each of the 6 students must have watched for 5 hours? And so basically what this is saying is to have an average of 5, does that mean everybody had to watch 5 hours? No. You can have an average of 5 without each number being 5. An example of that, if I look at, let's see, if there's 6 students here, maybe 3 of you watch for 4 hours and 3 of you watch for 6 hours. That might be an example of, well, that is an example of a mean of 5, but nobody actually watched 5 hours. So an average of 5 does not, well, let me write it this way. Sorry, I just want to get my thought right. You can have an average of 5. Without each number being 5. Okay. So with your partner, make a possible set of 6 values that have a mean of 5 hours. Okay, so basically there's a lot of ways you could do this. So this is just an example. As I mentioned, you could have 3 people that watched 4 hours and 3 people that watched for 6 hours. If you add those up, this is how we're going to verify it. 6, 12, 18. 18 plus 12 would be 30 divided by 6, which is 5. That's an example. But your examples, you could have people that watched 5 hours. Like, for instance, what if instead of this 4 and this 6, what if I had those 2 people watch 5 hours? Well, the sum is still 30, and when you divide by 6 data values, you still get a mean of 5. So that's just yet another example. So a couple examples there. So you would just come up with a list of values. You could get really extreme if you wanted. Maybe one person watched 0 hours, one person watched 10 hours. So like maybe this person 0 and this person 10. And if you add those up, 10, 20, 30, you still have 30 over 6, which gives you 5. So a lot of different ways you could do that. All right, so compare your list with another student's. Find their range of each list. Who is more spread out? So when we find range is going to be the distance between the max and min. So you're going to take max minus min. And so your examples might be different than what I come up with. In this example, my range with the data I now have on my list would be a range of 10, right? If I look at the example where it was 4, 4, 4, 6, 6, 6, that range would be 6 minus 4, which is 2. So could have a lot more. So let's try this one out real quick. Oops, it was 0, 4, 5, 5. The range here would be 10 minus 0, which is 10. If I look at the data that was 4, 4, 4, 6, 6, 6, it'd be 6 minus 4. The range would be 2. So just as an example, okay? The actual set of values for these 6 students was 2, 3, 5, 6, 6, and 8. Calculate the range. So the range, you would just take 8 minus 2, which is 6. So the distance between the highest number of hours watching Netflix and the lowest number of hours watching Netflix was 6 hours, okay? All right, so now let's look at a new concept here. So it says finding the range is helpful, but it doesn't tell us how spread out the data is between the minimum and maximum. So how can we find the average distance of the values from the mean? Okay, so the first thing that we are going to do is we're going to find the mean of the data. Okay, so find the mean of the data. So our mean here, we know is 5, because if we take 2 plus 3 plus 5 plus 6 plus 6 plus 8 and divide that by 6, we get 30 over 6, which is 5. So the mean is 5. The second thing that we are going to do is we're going to find the distance of each piece of data from the mean. Okay? So what that means is we're going to take our data values, the 2, the 3, the 5, the 6, and the 8, and we want to see how far away is that from the number 5. So the way we're going to do that, 2 minus 5 is negative 3. 3 minus 5 is negative 2. Let me write these numbers so they're underneath the data value. 3 minus 5 is negative 2. 5 minus 5, distance is 0. 6 minus 5, distance is 1. 6 minus 5, distance is 1. 8 minus 5, distance is 3. Okay? So those are those distances. So you just take data minus mean. That's what I did there. I'm taking the data value and subtracting off the mean. So then part C, I'm going to do this in, let's do it in orange. Part C says square the differences to make them positive. So we're going to take these, we're going to square them, we get 9, 4, 0, 1, 1, and 3. So we're just taking these values and squaring them. Okay, so we do that to make those positive, as we said. And then what we're going to do is we're going to find the average of those values. I'll do that in, let's see, purple. So what we're going to do now is we're going to add those numbers up. Notice some color coding here. And we're going to divide those by 6. 9 and 4 is 13, 14, 15, 16, 17, 18 divided by 6, so we get 3. Whoops, I made a mistake in this. Sorry, when I did that 3 here, for 3 squared, I should have made that 9. Oops. Sorry, so that's 9. So that's going to change the number that we get here. So let's see, 9, 18, 19, 20, 22. So that's going to be 24 divided by 6, which gives us 4. Okay? Now what we're going to do is we're going to square root to undo the square. I'll do that in light blue. So we're going to take the square root of 4, which is 2. Okay? And now what we want to do is we want to interpret this. So interpret the standard deviation. So the standard deviation is what we just calculated, by the way. All of this gives us what's called the standard deviation. So when we look here, it says the number of hours. So we're going to interpret this. So the number of hours watched by each person it is on average, my brain is going faster than my pen, is on average 2 hours from the mean of 5 hours. Sorry, it's kind of scrunched together there. Mean of of 5 hours, HRS hours, okay? All right, so that's what this means. So it says, so when we calculate the standard deviation, we're talking about how do these data values differ from the mean, and then how does that play into how it relates to the spread of the data. So the number of hours that are being watched by each person is on average 2 hours from the mean of 5 hours, okay? All right, so let's record some important ideas here. So the first word that we learned about, or that maybe you already knew, was range. And that's the distance between the minimum and maximum data values. So we calculate that as range is max minus min. And that just tells us how the data spreads overall from highest to lowest. Now, when we talk about the average distance from the mean, we're talking about standard deviation. Okay. And what I have here is a picture that illustrates this. When you look at the first picture, you'll see that this says a low standard deviation because the data values are pretty close together in the center. So the data values aren't really differing that much. So we have, think of these values right here as 3 different data values. The data is pretty close together. On this one, you've got a low value and a high value. So we have some extreme values, and so we have a higher standard deviation. The middle, there are no values in the middle, but the middle, the average of these data values is going to be somewhere probably here. But obviously these data are spread quite far from that middle. Okay, so that's why that one's considered high standard deviation. All right, so let's check some understanding here. So we have 3 different dot plots, set A, set B, and set C, and we're going to fill in some blanks with the less than symbol, greater than, or equal to make true statements, okay? So we start off with the concept of the mean. So the mean is the average. Okay, so the mean of data set A versus data set C. Well, if we look at data set A, we got 0, 0, 1, 2, 2, 2, 3, 4, 4. So what I'm going to do is I'm going to take a calculator and I'm going to add those numbers up. So the mean here is going to be, let's see, 0 plus 0 plus 1 plus 2 plus 2 plus 2 plus 3 plus 4 plus 4. I get 18 as my sum. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 red dots, so we get a mean of 2. Now for data set C, we're going to find the mean of it. So looking at that, it looks like we have 10 plus 11, whoops, there was another 10, plus 12 plus 12 plus 12 plus 13 plus 14 plus 14. I feel like an idiot now that I've added all of these up because I just looked at those numbers and they are most definitely higher than data set A. So I didn't even really need to calculate this, but I think we can easily see that data set A's mean is less than that of C. Now, when we compare the standard deviations, the standard deviation of set A, this is where making the calculations will actually be helpful. So really, I guess I did need the data after all. So when I look at data set A, the mean was 2. So when I have, let's see, -2, -2, -1, 0, 0, 0, 1, 2, 2. Those are my distances from the mean. So remember, you take the data value minus the mean, and then we square those numbers. So we're going to get 4 plus 4 plus 1 plus a bunch of zeros, plus 1 plus 4 plus 4. And we're going to divide all that by 9. And let's see, 4 plus 4 plus 1 plus 1 plus 4 plus 4. I get 18 divided by 9, which is 2. So we have a standard deviation of 2 as well. For data set C, the mean was 12. So looking here, I have -2, -2, -1, 0, 0, 0, 1, 2, 2. The data values are exactly the same. So when I square these numbers, I'm going to get exactly the same thing as I did a moment ago. And we had 9 data values, so those are equal. Okay? Oh shoot, that was for, sorry, I was thinking ahead to C. Sorry, let's put that for C. Can't believe I did that. So actually, going back, standard deviation of A versus B, well, let's look at it. Standard deviation for B, didn't calculate that yet, so I'll do that in orange. So I need to find the mean first. So 0, 0, 0, 2, 4, 6, 10, 14, 18. So we have 18 divided by 9, so we have a mean of 2 again. But for the standard deviation for data set B, I have -2, -2, -2, 0, 0, 0, and 2, 2, 2. Squaring those numbers, I get 4, 4, 4, 0, 0, 0, 4, 4, 4, which I need to add those up and divide by 9. So let's see, that's 24 divided by 9, which is about 2.7. So it looks like the standard deviation of B is greater than the standard deviation of A, because standard deviation of data set A was 2, but for B it was 2.7. And I already calculated how the standard deviations compare for data set A and C. And when we look at this, we could see that the data is shaped the same for A and C, so it makes sense that the standard deviations would be the same as well. Kind of something to think about. So our data values are increasing by the same amounts, and we have the same number of data values occurring in each of those individual spots. So when we think about this in a later context, you could be thinking about standard normal, but we won't get into all that right now. For part D, the range of data set B. Data set B is 4 minus 0 for the range, and for data set C, it's 14 minus 10. Both of those give us 4, so they're equal. Okay? All right, let's look at question 2 here. If we add a 12, or if a value at 12, how will it affect the standard deviation of this data? Well, if we added a 12, so we add out a 12, we've got a value that goes far away from the mean. So remember, the mean here is only 2. If we add a data value that's really high, we're going to really increase the standard deviation. So the standard deviation will increase because 12 is very far from the center. So the average distance from the mean will increase. Okay? All right. Now, if we look at the next one, it says, here's the next data set. If we add a value at 12, so if we were to put another dot here, how will it affect the standard deviation? So what's happening here is, so when you think about standard deviation, you're adding up all those distances, the squares of the distances from the mean. By the way, when I went back, I just realized something. When I go back looking at those standard deviations that I calculated, I forgot to take that square root at the end. I forgot to do that square root of the 2. And the reason that I forgot that was because I just was goofy. Didn't think about the fact that When you're doing the squaring, you have to then undo the squaring to get back to the actual standard deviation. We'll talk more about this later in a stats class, but what you actually calculated without doing the square root is called the variance, but we want the standard deviation, so take the square root. Forgot to do that on those, so I apologize for that. But anyway, let's go back to this problem here. So again, we've added on another value, added a value at 12. How will it affect the standard deviation? Well, so we're adding up all those sum of the squares. Here, because our mean was 12, so our mean was 12, and we're adding another data value that's exactly that mean, what will happen is the standard deviation will decrease because you're adding 0 to your list of all the differences that these data values are from the average, but then you're dividing by a 7th data value. So what happens is the standard deviation will decrease because 12 is the center, also the mean. So it'd be 0 away. Making the average distance decrease. Sorry, I'm kind of squeezing that in there. But that is essentially how we do this. You will probably focus more on interpreting standard deviation rather than calculating it as I've done here. But it is important to understand what standard deviation does to a set of data.